Now let's look at two very interesting questions from the CAT. The sum of four consecutive two-digit odd numbers when divided by 10 becomes a perfect square. Which of the following can possibly be one of these four numbers? Now, when I add up four consecutive two-digit odd numbers, right? Let's say I'm adding up 11, 13, 15, and 17. Now, without summing it up, we know that the sum has to be 4 into the middle number. In this case, that's going to be the average of 13 and 15, so it's going to be 4 into 14, right? Okay, now, so the middle number is going to be even always because it's between two odd numbers. And this is where the 10 is going to come from, right? So you need 4 into something and then ending in a 0. And then you divide by 10 where the 0 cancels off. And you're left with a perfect square. Now 4 is already a perfect square, so this has to be a perfect square. Now, a single digit perfect square can either be 4 or 9. So you are looking at 4 odd numbers around 40 or 90. Now if you look at options, then you don't have 21 is not around 40, neither is 25, but 41 is. And that's the only option. So you are looking at 37, 39, 41 and 43. If you add these four numbers, four consecutive odd numbers, the sum is going to be 160. Divide by 10 and you'll get 16 as the perfect square. So another way of seeing this whole thing is, which four odd numbers do I need to pick up? So if the odd numbers are going to be out of this 5, right? 4 odd numbers out of this 5, and it has to end in 0, then I have to drop the 5, right? Then 3 and 7 will add up to 0, 1 and 9 adds up to 0, which means my series has to start from 7, 9, 1 and 3, right? So a very interesting question and a nice way to solve it if you're comfortable with properties of squares. Now let's look at the next one. You have a perfect square, 4-digit perfect square. First two digits are same, let's call them AA. Second two digits are, not second two, the next two are BB, right? Now, AABB, whether it's a perfect square or not, will always be divisible by 11. Now, that's your first breakthrough, that the number has to be, the root also then has to be divisible by 11, right? If the square is divisible by 11, the root has to be divisible by 11. Okay, so that's one thing. We know now that the root has to be 11 or 22 or 33 and so on and so forth. Now let's really evaluate what BB can look like. We know that the unit digit has to be 0, 1, 4, 6, 9 and 5, right? Now BB cannot be 55 because we know it has to be 25. BB cannot be 11 because if your unit digit is odd, then your tens has to be even. Same reasoning, it cannot be 99. And it cannot be 0, 0 also because then double A double 0 will not be a perfect square, right? So it's either 4, 4 or 6, 6. Now a perfect square has to be a multiple of 4. So it cannot be 6, 6. 66 is only a multiple of 2. If it is a multiple of 4, it only can be 44. So great, now we are here that the number has to be AA44. Okay, now the root of this, since it's ending in 4, will either be 2 in the units digit or 8 in the units digit. And since the square root is also a multiple of 11, the number has to be either 22 or 88. So now we'll just find the squares of these two numbers. 22 we know it is 484, which is not of the form AABB. 88 square is 7744, and that is the only number that is of this form. So how many 4-digit numbers? Only one, which is 7744. So I hope the entire reasoning was clear to you. See you for the next set of questions.